So here we're going to work on solving systems of equations. There are several different ways we can do it. The book covers 3 different ways. And the way that we're going to solve this first one is going to be the equal values method. Since we're dealing with 2 functions here, f of x and g of x, remember that those are just the same as saying a y. So what we're going to do with this is we're going to set them equal to each other. So we want to figure out when, if that equals y and that equals y, we can set them equal and solve for x that way. So once I have it set up like this, I have now gotten rid of one of my variables. I only have x remaining, so now I can solve. So I will go through and get my x's on the same side by adding 4x, giving me 7x minus 5 equals 9. Add my 5. 7x will equal 14, and x will be 2. I am then going to take that answer and substitute it into one of these two, and it doesn't really matter which one. So I'm just going to take the f of x, and that is my y value, so y will equal 3 times 2 minus 5, which will be 6 minus 5, which will then equal 1. So my coordinate point here is going to be 2, 1. That is the point where those two will intersect each other and solving my system. If I look at a problem like this, you can see that this equation here is already solved for x. So when it's set up like this, what I'm going to want to do then is use the substitution method. I know what x equals. It equals 1/4 y minus 1. So I'm going to take that and plug it in right here for x. So I rewrite the top equation here. 4 times x, but now I know what x is. X is my 1/4 times y minus 1. And that all goes in parentheses. Minus my 3y, and that equals negative 10. Again, you can notice that I no longer have 2 variables. I'm only down to 1 variable. So I now distribute my 4 here. So I will get 4 times 1/4 is just 1, so 1y minus 4 minus 3y equals a negative 10. Combining like terms on the left side will give me a negative 2y minus 4 equals negative 10. Adding 4, I get a negative 2y will equal negative 6, and my y value is going to be a positive 3. Now I need to substitute it back in, so it's easy enough to put it right in that one because it's already solved for x. So I'm going to substitute that in. X will equal 1/4 times my y value that I just solved for, minus 1, which will be 3/4 minus 1. If you prefer decimals, you could use that as well. However, at this point, I'm going to get x to equal a negative 1/4. So my coordinate point here then is going to be a negative 1/4, 3. The third option we have then would be the elimination method. So in this method, it works best when both x and y's are on the same side of the equal symbol. I line them up on top of each other, and what I want to do is I want to add these two together so something will cancel out. The problem is right now nothing will. So I need to adjust this equation. So my top equation, I'm going to remain the same. That's going to stay as 4x plus 5y equals 11. But my bottom equation, I am going to multiply the whole thing by a negative 2. And the reason for that is I am going to get my x values to cancel out. So now when I distribute that negative 2, I'm going to get a negative 4x minus 12y equals a negative 32. I can now add these two together, and when I add them together, my x values cancel out. They are now 0. 5y minus 7y is going to equal a negative, or 5y minus 12y rather, will equal a negative 7y. And that's going to equal then 11 minus 32, which will be a negative 21. So negative 7y equals negative 21. I divide by negative 7, and y will equal a positive 3. Again, to solve for my other variable, I'm going to pick one of the equations and plug it in. It does not matter which one. I'll just pick the bottom one. So 2 times x plus 6 times my y value, which we just figured out, is 3 equals 16. So 2x plus 18 equals 16. Subtracting the 18 away from both sides, I get 2x to equal a negative 2, so x is a negative 1. My coordinate point then, negative 1, positive 3. And those are the 3 different ways of solving systems of equations.